Hi, my name is Mohit, and it would have been very nice to join all of you in person, but unfortunately, it was not possible. So I'm doing this presentation remotely, and I cannot hear you guys, but I hope you still can hear me well and enjoy the presentation. So if you can move to the next slide. So, as I said, my name is Mohit. I work as an experienced researcher at Ericsson here in Finland. I also work in the academia, so I'm a part-time postdoctoral researcher at the university here. In the past, I have been working as a visiting researcher at Carnegie Mellon for a few months in 2016. I have a Doctor of Science degree in computer science, and the title of my dissertation was Security for Ubiquitous Internet Connected Smart Objects. So basically, I have been working with IoT security for about five years now. And before my doctoral degree, I have completed dual masters of science degree from Sweden and Finland. This was a EU sponsored program where they kind of provide scholarships for you to live and study in Scandinavia. Next slide. So what do I do? Mostly applied network security research. So that also involves writing a lot of code, which can be in various different languages. But in addition to that, I also do formal modeling, and I also participate in the standardization at IETF. So I'm currently co-chairing two working groups. So one is this lightweight implementation guidance, which basically is not defining new standards, but providing guidelines for developers on how they can implement existing standards in a more lightweight fashion. So we have, for example, documents on how to do lightweight IKE, which is this Internet Key Exchange Protocol version 2. We are currently working on how you can do elliptic curve crypto on in a lightweight fashion so that it can be done on very small IoT devices as well. But no new standards are being defined in this working group. Then I'm also co-chairing this working group called EAP Method Update, and EAP stands for Extensible Authentication Protocol. It is widely used in network security. So if you ever use enterprise wireless access, then you then you typically use one of the EAP methods, and EAP is this generic framework where you can define as many authentication methods as you want. For example, there already exists EAP TLS, EAP TTLS, EAP PEEP. There is more than 50 methods that have been defined so far. And in addition to standardization and writing code, we also write research papers, not many, but some. And I have been lucky to receive a couple of best paper awards at ACM Ubicom in 2014 and IEEE IoT in 2015. Since I also work for a corporate that is involved in mobile network mobile networks, we also do a lot of inventions and patents. So I have been involved with patenting activities, mostly related to mobile network standards, and they are not based on the work I do at the IETF, but more related to 3GPP standard. Next slide, please. So maybe this is perhaps the most important slide in my presentation, and I can't hear you, but if you have some questions, perhaps Dr. Bala can type the question in Skype and I can try to answer. So one basic question is why to work on bootstrapping and secure bootstrapping? Because as a premier research institute, CDAC, IIIT, IISc could work on many other issues that we currently or that the internet currently face. And why do I decide to work on this, and why I would encourage all of you to perhaps look into this topic is because there are many protocols and tools for security that already exist. So we have TLS, and most recent version was 1.3. Then if you are using a UDP-based protocol like POAP, then you have something called as datagram TLS or DTLS, which is somewhat a little bit lighter weight than TLS. We also have Internet Key Exchange Protocol, which is widely used if you are ever deploying IPsec tunnels. Then you use IKE, and we have plenty of experience with X509 certificates. So if you ever connect to any website over HTTPS, you already use certificates and TLS. Of course, uh, one could argue that these protocols are way too heavy and they take thousands of bytes and so many round trips that they are maybe not suitable for the smallest battery operated devices. And that's why we need some more lightweight protocols. Uh, so from my experience at the IETF during the last 4 or 5 years, I have been pretty much going to all the meetings. There is very little appetite in standards body to do more of this uh, fundamental research work where you come up with new crypto algorithms like identity-based crypto or attribute-based encryption. I'm not saying people have not proposed this, but generally when people have proposed this in the IETF, they have been shot down. Of course, there is some work going on this quantum resistant crypto or future proofing our crypto algorithms for quantum computers, and that is certainly still up for discussion in the IETF. But anything else, you can spend easily 5 years on some protocol fighting with a lot of people and a lot of companies. And generally, they stick to what they already know. And since TLS and DTLS is widely deployed, there are so many libraries that already exist. So if you come with something new, it will be quite a big challenge. And there have been people in the recent past who have come with new security protocols that perform something faster or save a few bytes in the memory that they consume, but they have faced a lot of resistance and none of them have become RSCs yet. And then why work on bootstrapping is because even though we have things like X509 and certificates and TLS, there are some problems that always exist that have not yet been solved. So if I buy a new device, whether it's IoT device or not, and even if it has a certificate inside it, how do I tell that this is my device? Like, how do I associate it with my user account? So typically, if you use a laptop, you generally use TLS like X and X509 certificates and open Gmail, but then you have to enter your username and password to then say that yes, this is my account and this is my service. And how to do that when you have IoT devices where you really can't type in a username and password is still a challenge. And IoT devices will be associated with some user account because if some mishappening happens or your IoT device is misbehaving, you need some kind of accountability that, okay, this device in this building belongs to this user and perhaps he should fix his device. So for accountability reasons, you will need to have some user associated with every device. And then the second question is even if a device has a certificate, when I bring it to my home or I bring it to my office, how do I tell that, okay, this is the network that you should use? And then how do I tell my network, okay, this is the new device that I just bought and it is trusted and it should be allowed to connect to the network? So these are some persistent problems in security that have existed over many years. And it's not like there are not no solutions. There are actually many solutions that exist, many competing solutions, but it's still an open problem because we often see devices using the same password or same shared key on all the devices in the network, and that doesn't scale once you start to have many IoT devices, even in home networks. So this is why I have been working in this space for a couple of years, and we have looked at several different proposals. And today in this presentation, I will present one of these proposals. It is definitely not the only solution out there, And even if it's not completely clear what is this proposal doing, that's fine. I think as long as you get interested in this problem space, I would be happy, and this presentation would be useful. Next slide, please. So, uh, in this presentation, I will be very briefly talking about a protocol that we have been designing, which is called EAP-NOOB, and it stands for Nimble Out of Band Authentication. It's a new EAP method. As I said, EAP is this authentication framework where you can have many different authentication methods, and this is one method that uses a out of band channel. So you might ask, what is out of band channel? It's basically something that is not sent on the wire or on the wireless. Uh, so if you're sending some packets that you cannot see, then it's in band communication, and if it's something that you can see or touch or feel, that is out of band. So scanning a QR code, for example, is out of band communication. Or perhaps recording of audio is another example of out of band communication. So basically anything that we as a human can touch, see or feel is out of band, and then anything we cannot see that is going over the wireless link or packet on the network, that is in band communication. And here I have this timeline of how this specification has been progressing. So the reason I have this timeline is also perhaps to educate that standardization is a slow process. So it's not generally not the case that you write a draft today and in 1 year it will become RFC. There are cases, especially if you write informational drafts, then there is possibility to do it rather quickly, but still doing anything in 1 year is generally quite short time. So standards, like if you even look at other standards bodies like 3G, 4G, 5G, they generally are like several years, 5 to sometimes 7 to 10 years. IETF is a little bit faster, but still it takes time. So, for example, we started working on this protocol in 2016, perhaps even a little bit before that, but at least we started writing the draft in 2016. And if you are doing like defining a new protocol, it's not enough to write a draft. You of course need to have like a working prototype associated with it. So we have, initially worked on the implementation. We were going to the IETF a couple of times and presenting the draft and then getting feedback, improving based on that. And especially if you do security protocols at the IETF, it's not even enough to have a draft and an implementation. It's almost now required that every new security protocol that you bring to the IETF has formal model proving that it is actually secure. So there are many formal modeling tools like ProVerif, Xamarin, MTRL2, and those who are active in those areas for formal modeling will know these tools quite well. As an example, TLS 1.3 has several formal proofs that prove TLS 1.3 is secure, and that's why it eventually was accepted by the IETF and became a standard. And this move is still work in progress, so it's not a standard that is widely deployed yet. Next slide, please. So basically, what EAP-NOOB is trying to solve is the problem that you have with these kind of devices. So there is an increased deployment of these kind of wireless, whether it can be printers, it can be a weighing machine, it can be these cameras that you install at your home or small office, with which you can then monitor what's going at your home, or perhaps use it to monitor your kid that you have left at home, and things like that. And basically, the problem is that even if these devices have a certificate, once you bring them to your home, how do you now tell that this is my device or this is my printer, and how do you tell the printer that this is the network and this is the SSID of my wireless network at my home or office, and this is what you should connect to, and how do you then tell that this is the password that you should use for connecting to the wireless network? So these are basically the problems that EAP-NOOB is trying to solve. And currently, if you look at Wi-Fi networks, they use the same password on all the devices where you have to enter the passphrase. And that becomes very questionable when you start to have hundreds of devices in a network. So the scalability of having the same passphrase is definitely questionable, and this is why we are proposing a new solution. Next slide, please. So the challenges is rather obvious. You have, as more and more of these IoT devices get deployed, you have a scalability challenge. And you saw from the pictures on the previous slide that they don't have a keyboard where you can necessarily enter that, okay, this is my Gmail ID and this is my password. So this is my device. So they don't have a keyboard to do that. And of course, this will not just be used by you and I who are relatively familiar with many computer and information security issues, but also by average users at home and in small offices. So how to make something that's usable, and this is where EAP-NOOB tries to come up with a possible solution. Next slide, please. So EAP-NOOB is basically meant for bootstrapping these kind of IoT devices that I showed in the picture, like wireless printers and cameras and so on, which are connected to the cloud. So what we have seen is many of the devices are being connected to the cloud because it makes many things easier, like remote management and monitoring. So if you are using a wireless camera at your home, you would generally access the video stream through a cloud, or if it's a wireless printer, you would often want to send it print commands through the cloud. For example, Google Cloud Print does something like that. And these IoT devices have no information about you as the owner of this device or about your Wi-Fi network. And you need to now do two security associations. So you need to connect it to your wireless network, but also to your cloud service, and somehow associate with your account on cloud service. Uh, Next slide, please. So actually, you can go one more slide further since I'm running out of time. I will just quickly show the yes. So I will just quickly show how the architecture looks like. So here you have the IoT devices that you are trying to connect on the right hand side and some kind of a cloud server on the left hand side. And the idea is that some packets are sent on the network that you cannot see, but then some information is sent out of band. It can be in the form of scanning a QR code, or it can be in the form of showing a QR code to a camera or recording some audio. But basically, it's something that you can see, touch, or feel. And because you can see, touch, or feel, it provides this kind of extra security in a way so that it tells the server that this is the device that I'm trying to now connect, and this is a trusted device, so please let it join the network. Uh, of course, the protocol itself is much more complicated than this. It is sending many uh, security related things like DP helmet key exchange in the in-band channel, and then sending some kind of key confirmation things in the out-of-band channel. And this is something that is becoming now popular regardless of whether you are using EAP-NOOB or whatever protocol for bootstrapping, but many of the new devices these days expect the user to have a smartphone with which he scans a QR code, or then uses some app on the phone to input the username and password and then tap a NFC, or things like that. So this is a trend that we are seeing anyways in the industry, regardless of what protocol they use in the device. The fact that they are relying on the human to perform some small step before the device becomes functional is becoming common, especially in small office and home environments where the devices range in something like 50 to 100 devices. Of course, if you're doing like thousands of sensors in a factory, uh, probably you will not run this step on 1,000 devices by scanning or tapping an NFC card. And for that, you need a little bit more automated mechanisms. But since you are buying 1,000 devices, perhaps the manufacturer of those devices can already customize the device for you by putting your network information and your user information on the device. Next slide, please. So uh, I am running out of time. I will just cover this slide and then go to the last slide. So basically, it does something called as elliptic curve Diffie-Hellman over EAP, and then as I said, there is one step, one small step that the user needs to do, which is the out of band step. And the idea is that you only need to do this once. So when you buy a new device, maybe you need to scan a QR code or tap the NFC. But once you do it, you don't have to do it every day. So then it will this kind of a permanent association will be created, and then you don't have to do it all the time until you factory reset or you sell the device to a friend. Then perhaps you need to do this step again. Uh, Maybe you can do a couple of slides further to comparing it with other options. So uh, still further, still further. Yeah, comparing it with other options. So basically here I will not go to the list, but I have tried to compare this protocol with many other possibilities that you have. You could argue that if the device has an NFC, why can't I just tell it the Wi-Fi, SSID, and password? Well, because it doesn't do mutual authentication, and you still need to. If the device is like a printer that doesn't have input, then things become a little bit more complicated. So I had this slide in a way to compare this with other possible solutions, but that's not to say that you should not work on other solutions. I would in fact encourage you, and my hope is that with this presentation you find this area interesting enough to work on this. Uh, Next slide, which is my last slide. So you can join the discussion. There is a mailing list, so probably you have already heard that IETF does most of its work on mailing list. So currently there is some discussion on EMU at IETF.org. Of course, there is discussion going on in several different groups. This is not the only group. There is, as I said, a draft specification for this, and I would encourage you to read and comment and ask questions. And as they teach us in the university and in school that there are no bad questions, I really mean it. There are no bad questions or there are no stupid questions. So feel free to ask as many questions as you can right now and maybe later on the mailing list because we have so little time. And of course, experimenting and prototyping is always good. So if you want to learn about something new, one very good way of learning it is by actually implementing it. Then you start to find some issues, and perhaps you can even come up with new ideas. So I would also encourage you to experiment and prototype. And with that, I think I have spoken way too long. I finished my presentation. If there are some questions, perhaps you can type